The next panel features some disruptors. They'll talk about how we drive from piles of data to timely, meaningful decisions and actions with some unique use cases and applications. Please welcome to the stage our moderator, Dr. Erin Simpson, and panelists, Dr. Sarah Battersby, Dr. Karen Miller, and Auren, Hoffman, and Jeff Jonas.
Good morning, welcome. Thanks for joining us for the panel. Apologies, it's incredibly bright up here and it's all reflecting off my glasses, so we'll get going here. Welcome to the final panel of GEOINT 2018. I want to thank USGIF for bringing us all up here today and for hosting a wonderful event. So if we can give Keith and everyone at USGIF a round of applause here. And I also really want to thank this community for being kind of at the forefront of the data revolution, both inside the government and across industry. And I think one of the things that really makes the GEOINT community unique is the combination of data makers, collectors, analysts, and decision makers all in one space, all in one community. And I think we have that reflected on the stage here today. And so, having gone from designing and deploying some of the world's most exquisite sensors, from satellite imagery to GPS tracks and everything in between, we're now rightfully turning towards sense making. So we go from sensing to sense making, and I have every expectation that this community will be just as revolutionary on that front as it has been historically. We have a great panel in front of us today, and we're going to explore some of these issues, and I think they reflect that breadth as well. So we have Auren Hoffman from SafeGraph, Dr. Sarah Battersby from Tableau, Dr. Karen Miller from Los Alamos Lab, and Jeff Jonas from Senzing. So what I want to start with is with Auren, actually. And in your work at SafeGraph, you collect all kinds of information, and we're familiar with kind of the mantra of garbage in, garbage out. But what kind of data do we need to make good decisions? What kinds of data drives good decision making?
Well, the most important thing about data, and this is maybe obvious, but the most important thing about data is that it's true. So getting to truth is really, really important. The better the data, the more true the data, the more data you have, the less important the algorithms are. So you can focus on the algorithms if your data is like really messy and maybe not very good or very, very sparse. But if you have tons of data and it's true and it's easy and it's the ETL's all there, then even very, very simple algorithms will sometimes beat the most complex algorithms on data that isn't very good.
Excellent. Do you have a good example of kind of where some really good data drives better decisions, or where the fact that we have really crummy data just overrides algorithms that maybe we've spent a lot of money on, spent a lot of time on, but can't overcome the noisiness or the fuzziness of the data?
Yeah, sure. I mean, there's tons of public examples. Many of the people in the audience have seen things on computer vision, where the algorithms to detect sheep will over-index on fields, and it's actually the fields, but not the actual sheep that it finds.
There's wolves and dogs have the same problem, right?
Exactly. The wolves and dogs is the famous one as well. So, so you have all these different types of issues with data. There's a lot of data that's just wrong to begin with, and so it's really important that you don't trust the data. You should come in not trusting any type of data source. So even data as like simple as weather data is often wrong. Most weather sensors are not calibrated very often. They're either in the sun or they're in the shade, or they have lots of other issues there. And so even data that you might think is data you could trust, like weather data, is usually very, very wrong. Sometimes like off by 30–40% wrong.
Well, that sounds like a problem. Karen, you work in kind of a different part of this space. So in your work on non-proliferation efforts also involves both sensor design, but also a lot of data analytics, but not necessarily big data.
Right.
Can you talk a little bit about the challenges of analytics driving decisions with small or sparse data?
Right, so people talk about data analytics, they love to talk about the 4 V's. So they talk about volume, velocity, variety, and veracity. And a lot of the attention around data analytics goes to volume and velocity. So what I think of as the true big data problems. I work in a world where a lot of the problems are dominated by the other two V's, so the variety and the veracity. And in those cases, that is where the subject matter expertise and the domain knowledge within a given field becomes critically important. There's no substitute for the domain expertise. So you really have to understand the nuance of the problem at hand and how that maps onto whatever model you're building. So this could be in areas like, can we use simulated data to supplement some of our training data? And how do you validate models where, by nature, the thing you care about is a rare event? Can you build experiments? Can you build test beds, either virtual test beds or physical test beds? And then once you start extrapolating beyond the parameters that your training data comes from, what does that mean for uncertainty? So these are the types of questions that drive a lot of my work and a lot of the challenges that we have.
Interesting. Do you have a good example of a place, whether we're in terms of either designing new sensors or having to work with, fortunately, historically rare data for the most part, where you've had to figure out that modulation or simulation approach?
So a lot of my work has to do with sensor development, multi-sensor systems for process monitoring within nuclear facilities. And so the thing that we really care about is any kind of diversion or misuse of a facility. So to develop these instruments, we have to do a lot of training in representative facilities, but a lot of those facilities aren't going to let you do something that is outside their normal operating parameters. Nuclear facilities typically are not amenable to this kind of thing. So you have to get into the simulation space and understand from a physics level, what are the different parameters? How do you bound those uncertainties, and then how does that fold into the analysis for the thing you care about, which is by nature a rare event.
Interesting. Jeff, we've talked a lot this week already about advances in artificial intelligence and machine learning, and Auren here actually has sort of talked about this distinction between the relative power of data versus the algorithm. What is your thoughts on kind of how we might balance the investment between better and more data versus better and more algorithms? And kind of related to that, how we optimize, or do we focus on optimization, or do we look at exploration within these systems?
Well, over half the organizations that I go chat with about their goals with analytics, when they tell me what they want to do, what outcomes they want with analytics, then I ask them what data do they have, and then they describe the data. I look at them and go, not even a divine being could use that data and make those predictions. Are you smoking crack? And I've taken a few different customers over the years, and I've kind of weave them into this one particular story just to make it more real life. Is you go, what's your goal? What does your group do? And they go, we protect the supply chain. You're like, great. What are your goals with analytics? They're like, we want to find bombs. I'm like, oh, I love projects like that. Okay, tell me about what kind of data you have. And they're like, well, we have who sends it and who they're going to send it to and who's going to drive it or fly it there. And we have the manifest about what they say is in it. And I'm like, this is all fantastic. What else do you have? And they go, well, that's all we have. And I'm like, no one writes bomb on manifest. You will never find a bomb. Now, it's not good to give people problems without solutions, but the remedy is really more about widening the observation space, because I really think, to a great extent, we've got a lot of impressive analytics to apply to data. And some people have a lot of data, but it's just a giant pile of red puzzle pieces. And if you want to get really high-quality outcomes, you've got to blend more diverse kinds of data together. And so there's a little a practice about widening observation spaces. I blogged about this. I did a blog called Fantasy Analytics, and I have a little self-help section in there called Widening Observation Spaces, which is just some tips for people about how to think about what other data they might want to mix in with their existing data to get a better analytic outcome.
What are some of those data pieces you might try to draw in?
Well, I'll give you one example. I had a strategy group in a government asking me about how to see new emerging technology. Yes, you could watch Twitter. Yes, you could watch Wikipedia. And I started thinking, what other kinds of diverse observations could you watch if you're trying to determine that a new technology is emerging quickly? And the idea that I had for them is watching the Wikipedia edit page. Because if it's only one person or two people commenting on it, it doesn't show that it's really having any viral growth. But if it's got a real community of people advancing that Wikipedia page, then I think that would be a great place for additional signal or additional context.
Interesting. Sarah, on Monday, Director Cardillo mentioned the opportunities involved in automating a significant amount of the image processing at NGA, and Project Maven has already made a lot of advances on that front. When you think about kind of that space of automating large parts of the workflow, do you think of those challenges as primarily technical? Or maybe as Scott Hartley on Monday also described, that they were more anthropological. I'm trying to think, as he was talking about that, I was wondering, what do you do with all the folks who currently process images by hand if we automate that vast workflow? What does entry level look like once you've automated a lot of the rote tasks?
Yeah, I think we have to think about this both as some interesting technical challenges and some interesting people challenges, because the thing is that we're using these automated methods to create more information. But that new information still needs analysis. I think that we're really good at the end of the pipeline of, for instance, doing imagery analysis and doing some automated classification. But in terms of turning that into predictive analytics, I think that we're still really developing capabilities there. So when we think about what the future holds, it's really embracing both these technical challenges of how we do things and how we do them better, and then what is the human capital that's really needed to take advantage of what we're doing. Because we really drop the ball if we don't think about how humans are going to help us make sense of what it is that we're processing. And then with respect to thinking about, so what happens to all of the entry-level analysts, I think that we just see this fundamental shift in how we approach the entry-level analytics process. We're really looking at something that isn't a replacement for the human, but is really an augmentation of the human that gives us a greater product and a greater result at the end. And the reason you have to have this human in the process is because in the intelligence community, when you get it wrong, it's really a big deal. If Amazon gets it wrong, it's just kind of funny. But it's like I wait anxiously, every week for Amazon to put new ads on my husband's Kindle because they think that he's female, and I don't know how they've figured that out. But they always want to advertise romance novels to him. So the new ad comes up and it's like this shirtless man on a horse, and haven't figured out what their machine learning algorithm is doing because his choice of books is like the 800-page presidential biography. And generally those don't come.
Some of those are very romantic.
Some of them are very romantic, but generally you don't get like LBJ on a horse without his shirt.
Totally.
And so they got it wrong, and it was just it's really funny, and I get endless amusement out of this. But if you have this automated algorithm that says, hey, let's drop a bomb on this, and you get it wrong, that's a lot of a problem. So when we think about what these entry-level analysts might be doing, we really have to focus on how can we use them to really improve and augment the system, and how can we turn it around so the system is actually improving and augmenting the analysts. We've got flaws and biases in our models. We've got tuning that needs to be done. We've got to develop trust with these models, and I think taking those entry-level analysts and saying, here are some things that are going to make it so that you can make insights a lot faster, and we want you to learn to do the analytic process and to learn to use these models and to trust these models and to tune these models and to become part of the system so that part of your training is now getting to the point where you're going to be able to develop more interesting and more advanced models because you understand what's going on. So building up that trust with the human capital as what we're doing with the new analysts.
Yeah, this question of trust is actually really interesting because one of the challenges in moving from kind of data exploration to actually, whether you're doing predictive stuff or trying to really drive decisions, is how decision makers, either policymakers or other folks, are able to interrogate those findings, interrogate that data, get some sort of transparency into how the algorithm came to the decision it made. other panelists, would you have ideas on kind of how you build trust, not just in one particular data stream or one particular decision, but in kind of the whole workflow for data-driven decision making?
You know, if you look for disagreements in data, you get something that you think is true, but then you actually ask the question to look for disagreements in the data. Look for dissenting information is one way to flush out errors that you wouldn't see otherwise. I remember while I was at IBM, I left as an IBM fellow in 2016, but before we beat the game Jeopardy with that Watson project, I met with the principal investigator for maybe 2 years before that. And when he was describing me his approach, one of the things that he said that really captivated me is he said, we use these algorithms to make a decision, and then we look for the inverse to see if we can find evidence that says it's not true. And I went, oh, that's going to be very clever.
Yes.
Yeah.
Most folks would not do that second step, right? And that's one of the challenges in kind of, there's data analytics and then there's research design. Other folks have experiences?
So, I mean, I think the best way to build trust with a tool is to use it. And so I think the idea that a system can be developed in a vacuum and then just handed off to an end user, I think you're gonna lose a lot of trust, or you're gonna have a lot of skepticism in the validity of that tool if the operators and the developers aren't co-developing and working on those together.
So sort of an agile process of some sort.
In your field, can you use synthetic data and get good outcomes? Because in my field, that doesn't work so well. Like you really have to use real data and really get real world feedback. But in your field, can you make completely synthetic data?
It depends on the problem type. So a lot of the problems that I care about are dictated by physical processes. And so you can, we're very good at building computational models to simulate processes that are guided by the laws of physics. But when you bring humans in and you're guided by human actions, I think that's where
we're all going to die.
I think that's where it gets a lot more difficult. But I think in some cases you can generalize models, but I think there's a lot of trust building and a lot of validation that has to go along with that.
One thing you might want to is before you even start, you want to figure out where is innovation going to happen. And almost certainly innovation, like if you think of where's innovation going to happen over the next 20 years, it almost certainly is going to happen in places where we already have data, good data today. And so if you think of so let's think of areas where almost certainly won't happen. It's probably nutrition. So 20 years from now, we still will be having fad diets. We'll be doing different types of things because getting all the data about everything somebody eats, tied to their DNA, tied to their wealth, tied to their exercise, tied to their eventual life outcome, 50 years later, whatever, is going to be an extremely difficult way of collecting data. But, maybe if you think of something a little bit more micro, like oncology, oncology, the feedback loops are really just a few years. A lot of the data is already categorized pretty well by a hospital or something. And so we should see a lot of improvement we would in oncology treatments over the next 10 years, whereas we probably won't see a lot of improvement in nutrition.
Interesting.
I think about the how do you build trust question. I think you had a really good point of you have to use the system in order to learn how to trust it. And I always come back to the human side of what does it mean to be using one of these systems or to be trying to make sense of the end. And I feel like the really important things are, people both have to want to have an understanding and a curiosity about the system, but they also have to have some hypotheses going into it. I mean, I'm in a field where a lot of people come to me and say, I would like an answer. And we can give you an answer. But if you don't really have a good question and you don't have anything to judge what the answer is to help try and validate whether or not it's correct, whether or not it's appropriate for your decision-making situation, we really have a pretty big failure. We're never going to understand the limitations or the biases in the model if there isn't anything that we can hold the model up to and say, is there something unexpected that's coming out of this? And that's going to require the curiosity and the hypotheses and the willingness and interest in understanding what's going on in the model.
I used to joke that when I was working on big data programs at DARPA, that if you put it on a map, it must be true.
Oh, it is.
And so, which is interesting for the GEOINT world, obviously. But the number of times that we would do really experimental, really unusual, both data types and algorithms put them on a map and present them to fairly senior military folks, and they were like, oh, excellent, let's do that. It's like da-da-da-da-da, right? They were not quite yet keyed to some of the caveats that might go along with that. I'm wondering what that means. We talked about kind of what the new entry level might look like, but how do we think about training folks not just to be analysts, but to really interrogate data, right? Interrogate the collection, interrogate the algorithmic processes. Is that different than the way we train analysts currently? Or are there more skills that we need to bring to that? Or is it a different team composition than we might already have?
I think we should test for and hire for curiosity and increase the bias towards very curious people.
Any ideas on how we test for curiosity, Jeff?
You put them in a box, you see
If you could be a candy bar, what kind of candy bar would you be?
Kit Kat. Okay. Any other ideas on?
I think there's some interesting research that's being done. I mean, this isn't how do you hire for curiosity,
sure.
But it's like how can you help people with becoming more curious? There's a lot of interesting research going on with how we can explain what's happening with things like machine learning models. So I've been reading a lot lately about this thing called LIME, locally interpretable model agnostic explanations. I just like calling it LIME because it's the only part I can remember. And so one of the places I was reading about LIME was in a paper that brought up the wolf and the dog example. And if you guys, just in case people aren't familiar with it, what the people in this paper did is they took a bunch of images and they had a machine learning algorithm classify them. Is this a wolf or is this a dog? Is it a husky dog specifically? And they'd actually gamed the system and made sure that all of the backgrounds for the wolves were snow. So it turns out the model then gets trained, so it sees any light-colored background or white-colored background, and it says, oh, wolf. So regardless of what animal is in it, it's wolf. So then they took results of this when they ran it on other images, and then they showed panels of those to machine learning grad students and said, how well did this do? Do you trust it? Would you use this model? And a third of the machine learning grad students said, yeah, that seems like a good model. And if these are machine learning grad students, a third of them that were saying, I trust the model more than maybe what's going on in my head, that's the problem. But then when they introduced these explainers that said, these are the cues that the model is picking up on that's leading to a specific interpretation, there was a huge shift in how people trusted those models. So I think that's a really great direction that we can look at going with. How can we explain what's happening with models that lead people to understand the false positives, the false negatives, and the truths, and get them to then think about what led into this.
And to unpack those neural nets a little bit, really to get some forensic qualities. Jeff?
And this might turn out to be harder than we think, or going to take a while. And there's a paper that came out maybe a year ago, and it shows an image of a bus, and then you tinker with a few pixels. So visually to you and I, it's the same picture precisely. And the algorithm goes, that's an ostrich. And then there's a picture of a bridge, and you change just a few pixels.
Right.
And the computer goes, that's an ostrich. Same with a taxi cab. And if an adversary can get in that loop and have you think it's a bird.
Adversarial AI is actually a real confounder and a real opportunities for adversaries, potentially opportunities for us as well. I want to shift gears just a little bit. This is kind of my own pet set of questions, but I'm the moderator, so I get to ask them, which is that this idea of kind of secrets versus mysteries. So a lot of times people describe the intelligence community, what you're really trying to do is to get other people's secrets, right? You want to know if another country has a new bomb design. You want to know what their trade disposition, their policy is going to be for the upcoming trade negotiation. If a question, and the answer to that question is in a file drawer, is in the head of, is that a meeting notes from some set of humans, probably representing a state actor somewhere in the world. But there's also a world of mysteries, like just what's going to happen next. If you were trying to predict the outcome of the Arab Spring and you wanted to know if the protests in Cairo were going to topple the government, the last person to ask was probably Mubarak. Right? He did not have the answer to that question. There was no one in the Egyptian army necessarily to spy on to get an answer to that question. And so a lot of the things we can do in the data analytics space, it strikes me, are in this mysteries, right? Trying to unpack some of these mysteries. But those then become questions that are much broader, right? They're kind of unbounded. So if you think about the secrets, there's a list of secrets that we would like, right? There's a intelligence tasking. We are able to optimize around that. Mysteries, that sounds like a bunch of grad student research, right? So how do we think about, actually getting out and exploring some of these things versus checking off our checklist, processing all those images, and then being done with it?
I think getting the secrets is easier. Did you say you thought the mysteries was easier?
Well, I think secrets is comparatively easier because it's finite. I mean, it's a bounded set, right? But mysteries are definitely more fun. Well, I don't know. Stealing some kinds of secrets is awfully fun. It makes for good spy novels. I've yet to read the good machine learning spy novel, but maybe it's out there.
One of the things that we might need is just more of an HR revolution. And so we're starting to see really big changes in HR in very high-performing organizations, high-performing companies. Well, if you think of Amazon, so Amazon has this 2 pizza rule. So no team big enough that 2 pizzas can't feed them. So basically a team of 4 to 8 is kind of the ideal size of the Amazon pizza, the Amazon team. And I'm very hungry all of a sudden. And so what you get is you get these people who work incredibly well together, and then they have some sort of way of interacting with each other team, like some sort of for those of your software architects, you design your software. Nowadays, most people design their software in some sort of microservices architecture so that you can work in modules with each other. And Amazon is the one really that invented that microservices architecture. But now they're doing that in HR, which to me is the way bigger invention. And they're having these teams interact with other teams, and there's kind of some sort of API layer between the teams, maybe a human API layer. And so it allows them to scale very, very quickly. If you think of big organizations, you tend to have these massive communication problems and all these other types of things. And you're certainly going to have that in any scenario, even at a company really well run like Amazon. But it's going to be much better at a place like that. And I think we're going to need to have an HR revolution everywhere if we're going to take advantage of these types of expertise.
And I think we're going to need, we've made a lot of progress in information sharing, but I think we need an information sharing revolution too, because too many of the yellow puzzle pieces are still trapped over here and the blue puzzle pieces trapped over there. And if we cannot get those puzzle pieces together, you cannot get a sufficient amount of context to make high quality predictions. And I just think we have a lot, I think that's a real opportunity for America to really move that ball down the football field on information sharing. And some of our adversarial, these other countries are going to have an even harder time doing it. So when I think about what we can do that makes a really big shift, it would be really solving that.
Are you thinking commercial data? Are you thinking government collected data? Are you thinking both?
Really, it could be, you could just take even an organization that has its own data and data it owns. To sit in a government agency and have them go, man, that group over there in that other agency doesn't do a good job sharing. I'm like, you can't even share with the door to your left. So you could just start there.
To me, that gets to some of the less technical issues and more of maybe the fuzzy issues of policy context, regulatory frameworks. I think there are a lot of unknowns in terms of what the implications for machine learning AI might be, and how do you build policies within an organization that keep pace with this very rapidly changing technology and do it responsibly. And I think this could be one of these challenges that we talked about, the fuzzy and the techie, or the science and the art. Well, what about the technology and the policy, and how do we make that work in a way that is both not inhibiting technology, but also being done responsibly?
The question here from the audience that talks about sort of is the challenge for decision makers the type or amount of information available, or is it that they don't know how to quite ask the right question? And I guess said differently, how do we get, to the extent the intelligence community on the government side really is a customer-driven enterprise, right? They want to answer the mail for folks out in the field, folks higher in the policy apparatus. how do we get those folks to ask better questions based on the data that we might have available?
I have a contrarian view to that. I was talking to a counterterrorism intelligence analyst really early in my coming to visit with the intelligence community, having come from Las Vegas. It was in the early days, and I asked her, what do you wish you could have if you could have anything? And she said, I wish I could get answers to my questions faster. And in that moment, it really struck me as insane. And it was a 2-move checkmate. I said, but what if it's not a smart question next day? As more data arrives, it'd be a great question in a week. She goes, that could happen. And then I just said, what's the chances you can think of and ask every smart question every day? And she just literally looked at me defeated and said, I can't. And I'm thinking, again, I was very new to the community, I'm just thinking we're all gonna die if we have to think of every question. And it led me to a concept that it kind of reduced my work to, I'm more interested in systems where the data finds the data and the things that are relevant find you. I'm really interested in that kind of a flow. And what that means is every time your organization has a new piece of data arrive, including an emergency contact change in an HR system, or including a visitor pass at the front door, every time a new piece of data arrives, the enterprise just learned something. It turns out the data is the question. And that just changes it speaks to a kind of an architecture, and you could say a sense-making architecture, whereas the data arrives, it is the question, and then you're helping focus human attention. Anyway, so it's kind of it doesn't answer the question, it's kind of opposite.
That's okay. We'll do that for later.
Hence, I said contrarian. I warned you.
I mean, I think that presupposes that you have an organization with sort of a seamless data architecture and data management system. And so I think Sue Gordon talked about this yesterday in terms of data management. And my experience is a lot of organizations that have been around for a long time have legacy systems, the data is siloed, and it's difficult to just bring in a new piece of data and say, oh, this is going to open the door to some new questions or some new insights. And I think there's a lot more work to be done in the foundational pieces of how do you manage this data in an intelligent way that lets people query it and run analytics on it. And so I think there's
that's totally true. I'm just saying it's a goal. I'm like, well, let's go to there. That's the North Star. Let's go this way.
Yeah. But you can't forget about the fundamentals. So a lot of organizations are struggling with legacy systems, and I think that's the reality of it.
There is a hack that fixes that in a fairly straight way, but it might. I don't know if we get bored, I'll take 2 minutes, but go ahead.
There's a slightly different way of thinking about it, which is how do we optimize and how do we leverage the talent that we have? And in most organizations, most of the people in those organizations are not working on things that are really hard for them to do. And ideally, every organization optimizes its employees around spending as much of their time as possible. We'll never get to 100%, but that should be the goal, as much of their time as possible, working on things that are extremely difficult for them to do. For employees, that's the best state. You're going to be engaged. And
I definitely know some employees who would disagree with that statement.
Well, the best people, certainly people here, the best people are people who want to work on really hard problems, and they want to be engaged, and that's why you come to work, is to be like, wow, I want to work on something that's difficult for me to do, not impossible, because that would be demoralizing, but something that's hard, where you don't have a high, super high percentage of success, and maybe you only have a 50% chance of success or something. That's what we want to optimize people to go do. And today there's so much of people's time. It's like, for a lot of organizations, it's like 5% of their time is spent on hard problems, and other 95% is doing like rote things, or filling out reimbursements to go to GEOINT, or all these other types of things.
If we could automate expense reimbursement and the defense travel service, I think everybody would be very, very happy.
I mean, we definitely can. Yeah. I mean, we absolutely could do that. That is actually like a really easy thing to do. We absolutely could do that if there was a will to do that. We absolutely could do that, and that would massively increase the productivity of this community.
So another workforce question, also from the audience. Sarah and Karen had actually both mentioned kind of processes related to new analysts and the role of subject matter expertise. And so the question is, how do we think about career management or professional development for seasoned analysts? How do we integrate subject matter expertise alongside growing data analytics or sort of data-driven analysis? So as opposed to thinking about the entry point, if we're going to have some sort of revolution, we've got an incredible amount of talent, at what, on the government side, you would, GS 12, 13, 14 levels and, senior NCOs and whatnot in the military. How do we integrate them into a system that has more data-driven pieces?
Right, when you've got all of this great domain expertise and knowledge and people who are really thinking about what are the procedures for turning large volumes of data into information and decisions, you have to make sure that those people are integrated very closely into the whole process of designing automated systems and in training the new people in the systems. So even if you're doing a lot of automation, you're saying, well, what are we going to do now with all of the really smart people where, maybe some of their intelligence has just been baked into a machine somewhere.
Right.
Think of it as you can't have the Python expert that's writing all sorts of awesome code without really understanding the domain. You're probably not going to get deep domain knowledge from somebody who's been working as an analyst for 2 years. Even if they've got great Python skills, they probably don't have all of the gotchas and the problem cases that come up and all of the experience that you have when you've been doing this for 20 years. So lock them in a room and don't let them out until the data, never let them out of the room. When you've got someone really smart, chain them down. You just make sure that if the person that really has the domain expertise doesn't understand the model, that's a problem. If they don't understand the result of the model, that's a problem. If the person who's creating the model doesn't understand the domain and isn't talking to the people with the expertise, that's a problem. So then you get the room without windows and you lock them in.
Karen?
So I would have 2 points to this. I came into the analytics world not as a mathematician, not as a computer scientist, but as a sensor person. And the evolution in my field, we started out, when I started 10 years ago, we took very discrete measurements. And then we moved into persistent sensing. And I had upped my Python game, and I took a machine learning class. And then at some point, I tapped out on that skill. And now where we are is in the realm of multi-source data integration. And I, out of necessity, had to go out, find mathematicians, find computer scientists, learn to speak their languages, and get them excited about the problems that I worked on. So at some point, there's only so much that one person can do. And I think building these multidisciplinary teams is a huge part of that. The second point, Sue Calloway gave a presentation in the Foreword where she sort of talked about your career progression as a jungle gym as opposed to a ladder. And in my case, I had spent many years working in the same field, building a lot of domain expertise, but then at some point, the learning curve starts to flatten. And that's about the time that I had the opportunity to take a new position within my organization. It was a completely different field. It was a different role, so I moved from a scientist to a program manager role. I was exposed to entirely new ways of approaching problems and built an entirely new professional network. And so then going back into my traditional area of expertise, I have seen huge payoffs in terms of my ability to innovate and inject new ideas into the field. And I think from an organizational level, I think encouraging people to sort of get out of their silos of excellence and explore other fields, I think the more interesting work, the revolutionary work, is the parts that happen between those silos.
It's a really important, we shouldn't overinflate the value of experts. I mean, experts are really important, but the classic line, science advances one funeral at a time. Sometimes the experts can get in the way as well. And for those of you recently, Aubrey de Grey is he's a very smart biologist, but he just solved over the weekend one of the most vexing math graphing problems. And it was really amazing that basically a math novice came and solved this problem, and he just looked at it with completely new eyes. and was able to do it. He said he just did it over Christmas vacation because he got bored and he just wanted to do something different. And it's really amazing that he was able to take this thing on. And so we need the ability for obviously intelligent people who want to solve problems, but maybe don't come from a particular area of expertise, to come in and give them the ability to solve some problems as well.
I love this idea of a career as a jungle gym, which also suggests maybe that work should be a bit of an intellectual playground, which I think is actually pretty important for folks who are good at these kinds of jobs, whether they're actually writing algorithms or otherwise working in computational spaces. They are very problem-driven, and I think a lot of the GEOINT community is problem-driven as well. But it's also really fun to build teams. Do you guys have favorite experiences or tips when you think about building teams around, whether they're data science or more computational kinds of questions? What is your favorite way to try to think about building those teams? We talked about curiosity. What are some other traits or some other characteristics that you really hunt for when you're building teams?
I want my team to not ever leave.
Meaning what?
I want them to just keep working with me in a particular field. And it really gives me a lot of productivity when the average person on my team has worked with me on a particular domain for 15 years. We can have one half-an-hour meeting a week, and we usually finish it in 15 minutes. And the efficiency is extraordinary. So a goal I have in my team, and I mean, I have to bring in new people, but when I bring somebody in, I'm just thinking, I mean, I hope they never leave. And I just try to treat them in a way that's so respectful, and the work is so purposeful. But that's a goal of mine. Remember in IBM, my head of engineering, no one reported to me because I'm allergic to paperwork and country music, by the way, I swell up. But my head of engineering, I went to a VP and said, you are absolutely not to move him out of that job and promote him off somewhere else. And you can ask him straight up, but that's not his career path. We love what we do, and this is what we do. Anyway, so that's my comment on teams.
What other folks?
Keep them, build them, grow them, keep them.
There might be another way just to really focus on having smaller teams. So the way to have smaller teams is to really make sure that you leverage and really focus on people getting leverage. One of the things that most people, and even the smartest people I know, most really smart people are actually really bad at getting leverage for themselves. And so one of the things you can do is help them get leverage, spend money on them, show them that they're really important, and being able to help them get leverage, being able to help them buy time. The more the person is spending on really hard problems, the happier they're going to be. And any really high-performing person wants to work on hard problems. So the more they're working on hard problems, and give them leverage that don't have to do the other stuff. Figure out a way that they don't have to do these other types of things. And that could be lots of different ways, from outsourcing to creating technology, to giving this task to somebody else where it would be hard for them, to a whole bunch of other types of things. And that means you are going to have to have less bureaucracy for those people. You're potentially going to have to pay them more. So smaller, high-performing teams almost always that can work well with it generally are going to beat larger, less nimble teams.
I have to say, I always resented that prima donna model when I was running a small company, but it does have a place. Sarah.
Yeah, I try and think, what is this person going to be doing 2, 3, 5 years down the line? I mean, I agree with Jeff. I want to hire somebody, and I want them to be there forever. I want to get to know you. I want to form a team with you. I want to work with you. I don't want to think about hiring somebody who has expertise for something that is a particular project that I think is going to last for 6 to 18 months. I want to think about, do you have the skills for that project for 6 to 18 months, but do you have something that I really want in 3 years? Do you have this interest in working on hard problems, or maybe not calling them hard problems, but do you have this interest in working on things that are going to teach you something new, whether it's a new technique, whether it's going into a domain that's a little bit outside of your existing domain and you're really interested in that sort of thing, or whether it's just, I want to learn about these new data sources and come up with new questions, because it's the question that really gets me going. I want to find those people who are going to be around and have those questions in 3 years or 5 years, because they're just naturally people who want to dig in.
Karen?
I've had a couple of interesting team building exercises lately where we've come up with a concept for a problem, and there's probably some of the people in this room that I've worked with on this, but it's a problem that is so multidisciplinary. You pull in people from very different backgrounds, and they all bring a really critical piece to the problem. And you're sitting around the table and you're trying to figure out who is going to lead this team. And this has happened more than once in the past probably 6 months, where every single person in the room is like, I certainly can't lead this project. Like, I am not the expert. But every single person thinks, I don't have enough expertise to really see the entire vision of this problem, how it's going to come together. And to me, that's the sign of a really exciting problem, that you might be onto something that's never been done before, because nobody in the room has nobody in the room feels like they could potentially take on all the aspects of the problem. So I think that's a lot of fun when you fall into problems like that.
And then how did you pick a leader for that team? Did it all just fall to you? You went, well,
No.
Everyone else took one step back?
Everybody
And
rotated
usually
every week.
It's who actually has time to write the proposal, and that person becomes the leader.
Oh man, look busy.
All right, so last question for the group up here. We've heard a lot this week, both from Undersecretary Kernan, from Sue Gordon, from Director Cardillo, about a possible new artificial intelligence center, probably within DoD. It's best I can tell fairly underspecified, so we can imagine any number of possible outcomes. But what would be the one piece of advice, whether it's best practice or thing they have to do or caution that you might offer to folks who are designing and standing up that new AI center? We'll just go down the line.
So if I was just going to pick one thing, I'd say focus on the human capital first. Think about who are the people that are going to be designing the models that are being run by this AI center.
A well-known specialty of the Department of Defense.
The human
Focusing
capital.
on human capital,
Yes.
yeah.
Focus on the human capital. Make sure that you're giving people the appropriate training, the appropriate tasks, and really giving them the resources to think about the implications of what they're doing.
I think we're in a world like 1945 where there was a small number of rocket scientists and physicists in the world. There's a very small number of AI experts, roughly about 10,000 in the world. Of those, probably anywhere between 60 to 70% currently live outside the US. So I think for national security, the most important thing we could probably do for national security right now is have an AI visa and get those people into the room, get those people into the country. That would probably be the easiest, highest investment that we could make right now.
Security officers in the audience are all having panic attacks right now when you think about that, but it's a good point. Jeff?
I think to be efficient, we should have coordination and orchestration with all of the other great AI programs that are launching in all the other different parts of government.
Like where?
Well, like NGA.
Very well.
So I see one of the biggest problems that I encounter is bridging the valley of death between research and operations. Mm-hmm. And so if there was one piece of advice I had to give, it would be to bring the people doing great research and data science together with the people in the operational side who have an understanding of the problem space that nobody else in the world knows, and give them the time and the space to talk to each other, speak the same language, and then develop tools that are not only cutting edge, but also relevant to the end user. And so if there was one piece, I would say bring together a diverse set of perspectives in that way.
And figure out how the government should buy software. Excellent. Okay. Well, thanks, guys. That's been an excellent, excellent panel, and we'll let folks get out to lunch here a little bit early. So give me a round of applause for everyone here.